Hey everybody, how's it going? It's Saturday morning at 9:30 a.m. here in New York. I have 10 seconds, so wish me luck. Hit like and subscribe and all those things that kids say. And we'll see you in a couple of whatever. Oops. Hello everybody. Yeah, so so I jumped right to the first farm. Good morning. Sorry, it's been a tiring day. But yeah, it's way much 9 a.m. in the morning. So but yeah, I was very groggy at this time. I opened the palms. I even actually opened it a couple of seconds late, which I guess is not a big deal. But when I looked at this, I thought it was some weird binary thing. I actually misread this. I thought you're given like the first 10 digits and then you just kind of do the mapping or something like that. Like hey, this number maps to another like this set of string and so forth for each digit. That's why I was typing it out. Unfortunately, yeah, that's not the case. Um, see how far we get. So right now I'm just typing it out as much as I can, which is a little sad. Especially at least looking in the retrospect, it's a little sad. Uh, but yeah, right here I'm like, oh wait, where's the 8 and 9 and the 8 and 9? And I looked at and I'm like, oh, this is not the right problem. So so I just like, okay, how do I actually solve this then? And I was just like, okay. I mean, you could kind of see the pattern, which is that like, well, there's just like it counts to zeros, so it can have leading zeros. So I don't know if I thought about that at this point. I was just trying to figure out the pattern as much as I can, and like, or I mean, I think the pattern is like you can figure it out. It's just, and I'll explain this later in the thing in a stream, but 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 yeah, and I'm just trying to figure out how to code it in a good way. I actually thought for actually right now, I thought I was a little optimistic, so I thought that maybe it was something like if I just because I was a little bit rushing though. Yeah, maybe that's too much. Um, but I just thought it was n-1 to be honest, and then the binary. And keeping in mind of this for now, the numbers equal to 0, return empty string. But yeah, I thought this was just the binary representation of that. But it's a little sad looking back, see all my mistakes. I googled how to convert it to binary numbers, and I clearly did not do this right. So, so I definitely wasted a couple minutes here, just to even prove that I wasn't right. But I guess it is good practice. I should know how to convert to a binary. But oh, I think right here is when the sound on the other stream gets a little bad. So might cut it out, or maybe you still hear some keyboards, hopefully, and not just me loud. But yeah, so I got the string, and I was like, oh, this isn't even right. And I was like, okay, it's not something dumb because I think the thing with me here was I was rushing a little bit. I thought, well, um, it's an easy problem. Usually, I try like you have to get through a easy problem very quickly if you want to solve all four. So that's what I was trying to do. Unfortunately, it was not as easy as I was hoping it would be, and I was like, okay, let's sit down and actually look at what the pattern is. Okay, and I think I just didn't have the patience or the focus. Maybe it's a little bit in the morning, a little early in the morning, but the pattern is just like yeah, and I see that a lot of people, a lot of experts, kind of kind of save this one a little bit later, because mostly just reading and thinking. But after you figure out the pattern, which is that um, these are just binary numbers, except you have to take account the length, or they have leading zeros, so you have to take account the length, and then that's it. And unfortunately, I erased the if input is equal to zero, which I end up getting a typo on, or like a incorrect submission, which cost me 5+ minutes. I guess just 5. Well, 5 minutes plus a little bit of additional typing and so forth. But yeah, now I'm just like, okay, let's just manually simulate this and keep track of the digits and the number and number prefixes and so forth. Um, I just wanted to see where if this is close. Well, forgot to do the digits. What a silly this. And you see me like I think one thing I would comment on is that you see me keep running code just to kind of get these print statements. Some of that is just because I need yeah, more practice would kind of gain you the confidence so that though this one isn't like a coding practice, it's more mathy just to see that all the states are the same. So maybe I needed this one, but in general, I mean, you look at me struggle a little bit, a couple of minutes here and there, and it adds up, right? Uh, so yeah, definitely something to consider. And now I was like, oh, I'll just do the thing that I had from before, except for just to see if at least this is the right binary number. I knew that this was not in the right format, but I was like, okay, that looks good. Um, let's do this, but then it's still, I knew that this was still not right. Luckily, I mean, I knew that the test cases wasn't good enough, but so that I put in a few more test cases, though still didn't test for n equals to zero, which is a little sad. So I was like zeros, that means there's no leading zeros. So I have to factor that in. I was like, how do I do leading zero? I was going to do something like string forming with padding with zeros. And I was like, that is going to be, I mean, it's possible, but I didn't want to, I was like, yeah, like I could just do it, right? And it seems like I wasted like 20 seconds there. Uh, I mean, I point out all these inefficiencies in my coding so that or like my thought process, so that hopefully in the future I could improve on it. So uh, yeah, and then I was like, good to go. Let's submit. It's easy. And then I forgot the seal case. All right, went and test one more time first, which is kind of sad because I was like, Larry is not happy, but I mean I could have fixed my algorithm for it, but I was like, nope, it's okay. Let's just get it out. Except I'm like, what a silly mistake. Oh yeah, smallest common region. Yeah, I immediately have to keep reading a little bit. I thought this was LCA immediately, and I thought that well, not immediately. I think I have to read first. Look how tired Larry is. Or maybe look how tired I am now. So it's about the same. Um, but yeah, I mean, I think I recognize this as LCA very early. I think I mentioned that soonish. Um, but the problem is that I misread some of this problem, where I mean, because if you read this problem correctly, then you would notice that it is a tree. Um, and given a tree and an LCA on a tree is pretty straightforward. I thought that I think about this time, maybe a little bit later, maybe because I'm still reading, maybe. Um, I thought that you need a segment tree type thing on this problem, and I was like, last week I told people that I was going to learn segment tree, I didn't. So I was like, man, this is karma, right? But a segment tree will allow you to answer queries very quickly. But in this case, I didn't need to answer query very quickly. I just need to answer the queries once. So I was like, okay, can I do better? And yeah, I could just do an O-Van algorithm, which is yeah, just like shortest path going the other direction from the query, and then just take the shortest distance from both the regions. Right now, I was, and also I think at this point, and this is incorrect, but I was like, maybe I could do something like with topological sort, where okay, like the first element after you pop off the two queries or something like that, and you could have probably done something like that, but you would have to keep track of a lot of certain states to make sure that like someone's the parent of you and so forth. Um, and I look ahead to see if like there's a easier way, but because there's a lot of I at the time I thought there would be a lot of coding, which is true. There's a lot of typing. That is the way I was going about it. Um, but yeah, but if I do topological sort, I need to keep some sort of tracking of like parents and grandparents and stuff like this, and then it ends up being essentially also like a distance thing, or at least you have to do the same amount of work. So that's why I didn't do the topological sort, even though you could probably have gotten it, because in a way it's just worth researching that. I guess now that I think about it, um, yeah. I think after taking a scan at the other problem, I was like, I think initially I was like, can I just do this one, the next problem first and make it easier? And then I was like, just do it. I think this is doable. You could do it with a linear time algorithm. I think up to then I was still, like up to nowish, I was still thinking about segment trees. I think the other thing that here was that I thought you got multiple parents, and kind of my test case kind of indicates that. Because if you got multiple parents, then it becomes a much harder problem because you could have things where you could there are multiple routes from a region to its one of its ancestors, um, which complicates things a lot with respect to how to calculate the distance. And I think that's what I'm spending my time on here, mostly because I misread the problem. If I had read it correctly and that recognized that it's a tree, then I would have definitely gotten it, or I would have done the linear time frame immediately. But now, right now, I had my doubts, and actually, I think I just kind of gave up a little bit in the sense I didn't give up on the problem, but I gave up on trying to figure out the algorithm by just doing it, um, and then kind of see where maybe I could fix it later. Though, I mean, it turns out to be correct in that this is a tree and I just misread it, so I didn't have to change anything. But that was my logic at this time. And right now, I recognize that well, I need a inverse mapping, right? Because right now you have a list of parents and their children, but we want to actually, given a child, give it its parent so that you could do the distance search, in a reverse order. And that's essentially what I'm trying to do here. And I also, I yeah, right here I do some conversions between um, the string to its index, which I had some issues with. Well, right now I guess I was actually thinking whether I need that index, but I was like, do I need it? Do I not? And I wasted some time here just debating it as well. got the mapping done. I was worried about like zeros indexing, so it actually ends up costing me a little bit later, but yeah, and now I just finished up the reverse adjacency list, and then I was like, okay, let's just get this cranking. This is about 16 minutes in, so I've spent about 8 minutes on this problem. I thought I was at a good price, but it ends up that I still end up needing another 8 minutes, which is something that I definitely need to cut down on. Now I just find the distance between to both those regions, and then find the shortest to them. Um, and I was doing it with what do we call it, breadth-first search in this case. And this should be a pattern that you're familiar with, because this comes up a lot in Leetcode, it seems like. Um, though I was a little rusty. I'm tired, and I mean, even right now, you can see me blinking a lot. So I'm just way need more sleep. I think that's the short answer. Straightforwardish. There's a typo coming up that cost me. We'll see how long, but see if you could spot it. Yeah, the typo is still there. And now think I'm almost done, right? About 18 minutes into the contest, 19 minutes in the contest. Should be okay. I thought about doing zip. I probably could have done it. Actually, should have enumerated on this. It's just that I wasn't slick enough. I think something is that like I'm still a little rusty with the Python, or like not that I'm rusty. Like now that I'm looking at it, I was like, okay, this is a place I can be slightly more Pythonic. Um, but in the moment, I'm like, I just want to get it done. so so yeah, so that's something I focus on it. And there's another typo here which will come up in a bit, but because yeah, if you're a Python expert, you'll notice that you can do this still in the same for each loop. Um, so. Hmm. And this is just the distance metric, just the sum of them. Oh yeah, and right here I was like, okay, I actually need to reverse mapping to get the answer, so I just kind of append it here. I thought I was done. And I was like, okay, well, your for each doesn't make sense because it's on a range instead of enumerate, which is what happens when you change it. So I was like, okay, let's just change it. That one is a little straightforward, but I'm not getting the right results. So this is 20 minutes in. So I actually only, so if you want to count wastage, then I would have wasted about 3 minutes debugging this, which is, I mean, it adds up, especially since I had other issues on this farm as well in terms of coding. Um, so I print out the arrays just to kind of see. Um, Good thing about Python is you can print out arrays without too much work. And I was like, okay, so it's not visiting anything, um, which leads to a series of additional print statements. Well, first of all, I was like, oh, I need to actually fix this so that when X is, you know. Also, there's another typo here. This is just too early in the morning, right? I don't even know where the -2 comes from, to be honest. And I was just like, oh, what is going on? I just need to solve this. Because this doesn't make sense. I was like, why is this still giving me Brazil? Um, oh, and I was, yeah, that's another typo that comes from being early in the morning. So I think the actual debugging is pretty not bad. It's just that I have a lot of issues in a lot of places. Uh, and right now, it's like, Quebec doesn't make sense. It should not return anything. It should give me an error because it doesn't come up. Uh, so I'm trying to debug that, and I'm notice, yeah, X views. I don't even know. Um, and then here, right there, and at that dot, I was like, well, so yeah, so it correctly gives me a none. So I think the lesson there is that even in wrong cases, you could kind of use that to debug what your expectation is for your code, so that you could kind of debug them one at a time. Um, and I think also a better Sentinel value with best was like 1 billion, and if my distant array started at like 1 million or something like that, some infinity, then this wouldn't have happened. I wouldn't have to have a special case for x and y not equals -1. So, and that's actually I was thinking about that when I was coding, like in that moment of debugging. So still get the one-time error. I looked at the standard output. Um, yeah, I was like, that looks okay, but why is it not going? And this typo is still here, which is so sad, so sad. I was like, am I doing? Is there an off by 1? Am I doing it a little bit really? So I'm just gonna print out here. Like, okay. I mean, I was like printing. It does look at the parents. Like Quebec has a parent, New York has 2 parents in this case, even though it's wrong, but I didn't know that at the time. So I was like, okay, what is wrong with this? And I was like, oh, distant is not equals to -1. Ugh. Yep. And then now I'm just double checking my answers. Actually, and this is something that also adds a little bit is I don't like, I have, the reason why I always comment it out before I submit is because I printed it out. I've done in the past where I printed out, like, you print out so much that it actually ends up giving you a time limit exceeded, uh, just from the input output. So that's what I was trying to avoid right there. Um, yeah. So this is something, this problem I should have done a lot faster on. I think immediately I knew what to do. Though well, immediately I knew the top level, the high level task that I did do. But I actually made a mistake here in that I thought I could just do something 2 to the n, because and 2 to the n will be fast enough, because if it's not fast enough, then it's not, you know. But like, I mean, for 2 to the n where n is equals to 10 will be fast enough, is what I was going to say. But first of all, just setting the words in context. And I think I conflated the two things right now, still in my head, where n is equals to number of words, but also the number of synonyms, which is a little bit, I mean, it's not true, but I was, in this case, I mean, because both the upper bounds are 10, so which is misread it. And I thought I could do something like 2 to the n, and I go over synonyms and then, look up again. And this is pretty straightforward in the sense that this is the power set masking type code. And then I was like, wait, how did I get the mapping? Because right now my mind's on the next line of code, which is the getting the string one. I'm like, oh, I have to look. I need a mapping table. And then I was like, wait, looking at the example again, it's not just binary because happy could be joy, but then joy is attached to cheerful. So like, there's a connected component there. And right now, yeah, I mean, I think in retrospect, maybe I should have done some kind of union find instead. Um, maybe it's whatever you feel like it's easier to type. It's right now it's about 26 minutes into the contest. I was just trying to figure out like what do I need to kind of calculate the connected components. And there are a lot of ways to do it, right? There's depth first search, breadth first search. There's union find. All of them are O of n, where n is 10. So yeah, and then I chose to go to do the n cube way because n is 10. But first of all, I wanted the and again I use a mapping table, which it's not terrible, except for that I just have so much issues with it. Or like I had some. Well, it's not because I have issues with the mapping table. It's that, like I said earlier in the in this problem, even I would still have conflating. I mean, I think now I knew that these are not the same numbers in my head if I thought about it, but I was using it like there's still somewhere in there where I thought they're the same thing, like n, where n is the number of words, and also the number of words that appear in the synonym, right? And for here, I think I used the variable count. Yeah, I'm just typing it out. I'm like, okay, maybe I should just. Basically, it's the same idea here. This is basically an adjacency list of the synonyms that just append to each other. But then I was like, oh, but I still need the transitive closure, right? Well, it doesn't have to be transitive closure, but just like the sets. I mean, right here, I was like, oh, joy has happy and cheerful, but you know. Yeah, because here joy is connected to happy and cheerful, but happy was not connected to the other one or something like that. So I was like, okay, I need to do the other thing where we did before. And actually I ended up copying and pasting. I don't know why I did this way, but yeah. I was just trying to figure out what to do now. I was just going to copy and paste. That's what I end up with. And then editing over it. I don't know. I did this in a weird way. I think it's a little bit early in the morning. I wasted like 2 or 3 minutes even just doing this. I could have just typed that out really quickly. In retrospect, I don't know why I just waited for a copy and paste. And actually, in this case, I did okay in the sense that I didn't make any silly mistakes in the typing. But I actually, this is very easy. Like this is like this could easily have have typos. So I'm not happy with kind of what I did here necessarily. Just type it out. That's my recommendation. But yeah, that maps out all the synonyms and the things. So then, okay. And then the rest is just depth of search. Oh, well, not yet. Sorry. I have to do, now I have to find the sets. And here is where I start making mistakes. So if I could have gone in, maybe I could have gone a few minutes. Because I used n here, even though this actually should be on count. Here I was like, what am I doing? And now I'm actually just setting the bounds, or like setting the because now we have because what in my mind this was an adjacency matrix instead of an adjacency list, and then yeah, just do a quick print just to make sure I'm relatively okay. I actually ended up didn't really read this anyway, so it was a waste of a couple of seconds. But yeah, and right now I'm just doing Freud Warshaw for transitive closure. This is kind of actually, relatively speaking, anyway, straightforward-ish, or like from actually an algorithm that I don't see very often anymore. I feel like when I was starting in competitive programming, I've seen this apply way more. But maybe it's just one of those things where that was the only thing I knew, so I knew it more. But so it's kind of fun to kind of get back into it a little bit and using this algorithm. So yeah, so that's the transitive closure. Have some syntax error, but that's okay. Oh, because I was using and stuff, and I read it in my mind, but I think I was just using other languages or something. So I'm playing around with. I've been playing around with PHP actually recently, so that's why I use the semicolon a lot. But yeah, here I was like, okay, this looks okay. I mean, maybe off by one because I didn't have 0, but now it's time to implement the recursion and depth first search. Unfortunately, it seems like I still take 11 minutes here, which is really sad. Because that part should like not be 11 minutes. So we see what happens here. I was debating different ways of kind of keeping track of the running count, or not the running count, but just like the running state of the world. And that's kind of what I'm doing here. Oh, and I think for whatever reason, I was ready to return just the array right now instead of keep going. Man, I mean, I think now that I remember this part, about the next 10 minutes is me making silly mistakes. So I feel like I definitely could have, chopped up 10 minutes in this problem would have been great, obviously. Made numerous mistakes here where x is, and again, this is what we were saying earlier, where I'm mixing x and y's and whatever, and I changed this to, I I was debating whether just like use his own, like use the same word as itself, but I was just like, okay, let's just make that one of the sandal cases, which is okay. I think this part actually I'm happy with. But yeah, X and the Y, and then I was just like, okay. I was like, I don't need the array. Let's see what's up. And I was like, huh, nothing, huh? And then I think yeah, well, okay. I was hoping that I thought I realized. I just look at the distance away. I'm like, okay, maybe I'm off by one. And I am, but for a different reason. I'm like, okay, I mean, the way it's constructed, I see some truths and some forces. Um, I was like, am I off by one? No, no, no. What I need is that I'm confusing the words and then whatever, the words and the synonyms. I was like, maybe that's better. Maybe I just had a weird indexing and still nope. In fact, it's worse. But I think that's this case. It tells me that something that I didn't realize before, which is that like something is off. I was like, how can X be out of bounds? And I was so at least it led to something. Because then it actually goes out of bounds after the first element, um, which I was like, huh. And then well, there's that, but you need to fix that. And then now I'm getting out of bounds on the last element. And I continue to do this for about 6 minutes. So very sloppy contest for me. In that I know I could have done better, but and then here I'm like, what is going on? Why am I getting eyes and happies and whatever a lot? I was like, okay, let me print this out in a different way. Couldn't figure it out, but yeah, the short answer was that I was treating the yeah, I was like, yeah, just give me something more fundamental. And I think actually, yeah, okay. I was like, all the eyes kind of, yeah, well, even highlighted for emphasis to be like, what is going on? Why am I doing eyes? So, and I realized that eye is probably not in the mapping table because it doesn't show up, and that's fine. And I think I'm just beginning to think of how to handle it because I was like, oh, this is not in the table. Then just yeah. And I was hopeful, but I was still seeing I am I, so that's not great, obviously. Hmm. And this is finally when I realized that I'm using count incorrectly, or like I was doing it in the wrong places, and now it gives me a lot of out of range indexes. And I was like, okay, that means I need more. Let's print it out real quick, see where we get to, and then look at line 27. I'm like, okay, why is that bounds? Oh, it's because I'm still using it. And I am what I am. Now, and I was like, happy? What? Why is this not right? Oh, because that should be the mappings or the reverse mapping of the y index, and it's off by one. But well, this one's not actually not off by one, but some else is off by one. I mean, it's also off by one, but I had to fix something else first as well. I think no, maybe not yet, but I also realized that that our return values are not strings. Like, hey, is n right? I just had a lot of issues of this y and between the count and the n. Yeah, and I think that's the remaining kind of 2 minutes is me debugging the ends and the count. I mean, there's another place where if you see it, basically if you see an n, there's a good chance I was wrong, though, except for that one n there. Excuse me. Excuse me. Excuse me. Huh. But yeah, after fixing that, oh yeah, and I ran into some issues with kind of the judge, so I had to refresh. Luckily, I didn't have any specific cases. I was taking a look at the problem real quick. I was like, what? Some kind of counting problem. I could do it maybe in theory, it's dynamic programming properly. I did a refresh and it loaded really quickly, thankfully. Otherwise, it would have cost me more time. Again, we peaked at about 80 people finished it, which I was like, yeah, okay, fine. I was like, okay, this is good-ish, except for the one time. I was like, am I a place? The answer is yes. I was like, first of all, these are not strings, so let's fix that. And then the other thing was I still have a 43. And this was actually something that I knew from the beginning, but then I had to fix again with the count off by one count because I started with the one index instead of zero index. I was like, okay, this looks right. I'm not going to take that much time on it. Cool. And then I submitted and finished. This one, I think I knew. I just want to refresh just to see. Wow, I was like 10 minutes. Okay, so this is doable. Nothing tricky. I didn't really look that hard into that because I just didn't want to spend more time on that. Or at least looking at how other people are doing. I think I could have done this. So yeah. So I think maybe not immediately, but I was like, okay, this is just calendar numbers, which is something that's very common. And it comes up a lot. I mean, if you watch my stream, I actually mentioned this a lot. So I was like, this is calendar numbers. That's just implemented. Um, but I was just doing, I think I was just doing some maths on the first few numbers just to make sure. Um, Probably could have gotten this faster now that I'm watching it live, and it was slower. But I was just really tired at this point as well. Um, I'm still am a little bit. Oh yeah, and actually, I think right now, I mean, I knew it was calendar numbers, but I just was double checking the recursion or the recurrence. Um, but I was like, I got this. Let's just code it up. Cool. But yeah, but yeah, I mean, if you want an explanation on this problem, I'll put a link on below. So go look at the description. I think I'm gonna end this kind of commentary. I don't think I have anything tricky here. I just implemented very quickly, except I have one typo. Find this typo and then go to the end and then see if you find it while I'm coding it. Okay, cool. See you in a couple of minutes. Oops, and press the button. Hey again. Yeah. So just gonna review the problems again. Hmm. Yeah, the first one is it's difficulty easy, but the pattern. I mean, it took me a little bit. I misread the problem also. I thought it was some kind of one-to-one mapping, and I ended up wasting a couple of minutes there. But um, but overall, I had I had this type that I don't know why I erased it for a more general case, but and that cost me 5 minutes. But essentially, you have yeah. One number that has zero length, two numbers that have one length, four numbers that have two length, and eight numbers that have three length. You see the patterns, so it's two to the nth length. So I do that. I was trying to do something fancy with binary numbers, but I just end up simulating it as you see here, and then converting it with Python, and then adding leading zeros back in for that number of digits. Overall, okay. I mean, and a lot of people have gotten it right now, so you just have to grind it out. Excuse me. Smallest common region. I actually misread this for a long time. I thought this was a little tricky, but I actually misread this as there is no guarantee that R2. So that means I thought there'll be multi-parent. So the short answer here is that it's LCA, which is lowest common ancestor. And in general, for queries, you could use segment tree, or there are even O of n an O of one query time ways to solve this, but because you're only given one query essentially, you could do this in O of n, and that's essentially what I did. I used the buffer search to get the distance, and then just get the closest between the two of them, and that's it. I mean, and it's a tree, so it's pretty straightforward. Oh, I left in the print statement, but I had a lot of I have some issues with typos, unfortunately, because I blame it in the fact that it's too early in the morning. But yeah, overall an okay problem, and by now 600 people have solved it. Yeah, and yeah, it's all event, so the length doesn't really matter in this case. But cool. Synonymous sentences. Yeah, this one I'm not super sure about. I think it's um, yeah. I mean, I because you could make this yeah, because this is, I mean, so what I did was brute force in slightly clever ways, but not really. I mean, I used Ford Warshaw to calculate the transitive closure, though it is also actually connected components, which you could use either union find or depth first search, but or breadth first search, or any of the kind of connected components algorithm. So what I did was O of k and cube instead of O of n, but that's fine because this in this case is n is 10. The bigger case is that it could be n to the n algorithm with the exhaustive search, but I guess clearly the input is a little weaker. It's not as specified as it should be, maybe, because it could have almost 10 words, right? So I think that's a little weird because that could be 10 to the 10, but clearly it's not because, well, if you do it brute force, your algorithm is, or like in a, let's say not too stupid way, too naive, then your algorithm is going to be as fast as the number of output, because it's n to the n, but there's n to n the output, so you can't really do faster than that, right? Well, except for what I did is I ended up sorting instead of kind of doing recursion in the right order. I could have probably sorted the mapping so that that's the case, but in any case, yeah, so that's kind of the algorithm. You could definitely make this timeout with 10 to the n for sure. So I don't know what the intended solution is. So I guess we'll see maybe in a little bit. And then handshakes that don't cross. Actually, on my regular stream, my Twitch stream, link below. I talk about the Catalan numbers a lot, and it is something that comes up a lot. But it's easy to remember as well as long as you implement it correctly. Unlike me, basically you kind of, if you think about the brute force of just like going around the circle, let's look at the number, I guess in this case 1. You could look at 1 connected to 2, 1 connected to 3, and then 1 connect, well, you can't connect to 3 because that chops off the 2, but just imagine that it goes around, right? So that's your I loop. And then if you look at the line, the left and the right, and then you multiply the number of possibility to the left of the left to the right, right? That's all it is, the column number. So it comes up very frequently. The recurrence is straightforward-ish. If you have to take care of mod, but if you're in like me where you add them instead of multiplying them, and that cost me a couple of minutes, even though I probably implemented this like hundreds of times, which is kind of sad. But I blame it on the mornings. It's too early in the day for me. But yeah, I definitely recommend read up on calendar numbers, and also this is not Python. So yeah, so that's kind of the suggestion I would have, and that's how I would solve it. And that's how I did solve it. And imagine, I mean, people got it very fast. What? I mean, okay. I mean, I don't know if he did both of these in parallel, but also to be honest, if he actually solved this in 13 minutes, I wouldn't be, or 13 seconds, sorry, I wouldn't be surprised because this is pretty textbooky, and it still took me 9 minutes because I'm not need to get better at the coding portion today. But yeah, overall, yeah, I can't complain on top 60. I don't know if this rank keeps on fluctuating, but it seems like it should be settled now. Top 60. Let's see. Where am I? Where is Larry? I don't know, but overall, yeah, I mean, I always have one silly mistake, so I've got shaved 5 minutes. I think I could probably gone maybe 5 minutes here and a 5 minutes here, and maybe just say 3 minutes here. So if I had gone 18 minutes quicker, I could have been, let's see, top 20. So that would have been great, but it didn't happen, and that's where practice is. I think that actually is it's sort of a good thing because I mean, I say this a lot, so so hopefully it's still true, which is that I have room for improvement. It's not that I've reached my max, right? So yeah, wow, he beat the field by 16 minutes, so it's not actually that close. But yeah, okay. I mean, I'm going to review other people's solution next. Stay tuned, and remember to subscribe. Hey, yeah, this is the end. Just going to go with the other people's solutions real quick. This is a segment that I always try to do because I'm just trying to see what's yeah, try to see if I can learn anything. Cool. Let's see. I mean, I think the good thing is also AWICE is also, or AWICE. I'm sorry if I messed that up. It's always in Python, so I can learn. But yeah, the first problem, what did I do? Oh, that's the binary encoding one. So let's see if I can be very quick about it. Okay, I mean, he just did the brute force very quickly. Yeah, should have done that. But yeah. Actually, this is a little weird, but maybe not. He just did it by a race, I think. But yeah, smallest regions. Wow. Yeah, I mean, I think. Yeah, I think the reason why I spent so long is because I actually didn't realize that you don't have one parent. Otherwise, yeah, definitely this is the way to go. Just keep track of parents and then go up the tree. But yeah, and then it'll be the first, because it's a tree, the first parent that are both common will be the answer, which is much smarter than I did, and also much easier to code. I mean, this is a much less error-prone 10 lines of code. I did too much with the mapping. But that's an algorithm thing. I think everyone, actually, I mean, everyone did it this way, but I guess some of that is that, yeah, I mean, yeah, everyone did it this parent route, but that's just because I misread it, I think. I think this one, yeah, which is unfortunate, I think, for me, but it's fine-ish. Cool, third one. This one is the brute force one. Yeah, they did brute force as well. I have to figure out what product is, but also brute force. I guess everyone's just brute force in some way, and having some mappings. But this is, I guess this one is a little bit more. I mean, well, he did it in 4 minutes, but for everyone else, Everyone else is just, I mean, it's not hard. It's just there's a lot of typing, a lot of places to get wrong. I mean, look at this. This is a lot of code. So I don't know if I'm, like, I probably could have still done, I mean, I definitely could have done better on the coding, but I mean, in terms of reading it and immediately understanding this is not Trigger as well, right? Like, I mean, these are hard to read on, so I'm okay with what I got, except I should have done it a little faster. And then the calendar numbers, yeah, I mean, this is the calendar numbers. This is the other definition of it with binomials. I think I always like the recursion, the DP one, because there's less chance of overflows, but that's maybe my limited understanding of this problem. Because this is a big number and there's no mod here, right? Or am I assuming it wrong? Yeah. So yeah, I don't know. And this is a modded power, which is way cheaper. But I guess I guess in 1,000 even long int is fast enough. So maybe that's why I was a little worried about kind of doing it that way, which when you're not using Python is always a little tricky. This is definitely way cleaner. I mean, I mean, I spent 9 minutes on this, which is a little sad, but like overall, this is not a hard problem, right? Like I got this really quickly. It's just that I had a silly plus instead of a multiplication, so it cost me a couple of minutes. But yeah, I mean, and I think I could definitely learn to be more intuitive about bottom-up dynamic programming instead of memorization all the time. I think that's the only thing. Because look at this. This is tight. 2 for loops. Okay, well, this has a lot of pre-processing stuff. But okay, this is too long for me to read. Oh, I clicked on the same one. Yeah, I mean, I think essentially everyone, I did one of the 2 variations, which is, but they're all the calendar numbers. So they actually probably Googled it. I mean, I don't think, or maybe other people just know it. I don't know, because I feel like I do not know the other recurrence by heart, but some people do. And I think this is very straightforward to program otherwise. So, yeah, cool. Well, 60th of 2,700. Can't really complain. Was a good contest. Oops. Hit the subscribe button, hit the like button. I'll see you next week on next contest, which is actually, I guess, tonight, but I'll see if I do it. But until then, thanks for tuning in.